We are going to demonstrate frequency division using asynchronous counter. So let's say we will deal with 3-bit counter. So we have 3 flip-flops, 3 T flip-flops here, 3 of them, and they are T flip-flops, and this clock, they are rising edge clock, the sign shows, and this is Q0, Q1, Q2. Let's mark like that. Now we have this, we will do an asynchronous operation. So the first one will be connected with the system clock. The first flip-flop's clock is connected to the system clock. They will have different clocks because that's why it's asynchronous. If it were synchronous, they would have all would be the same clock. So this output of the first flip-flop will be connected with the clock of the second one, and output of the second flip-flop, I will use a different color maybe, output of the second flip-flop is connected with the clock of the third flip-flop. That's how we will do, that's how we will connect the clocks. So all the T inputs will be 1, so the flip-flops will be in toggle mode. If the output is 0 with the clock, it will become 1, and if the output was 1 with the clock, it will become 0. So let's draw the clock. Let's say the system clock is like this. And since it's rising edge, so at these are the edges where the flip-flop will experience the clock. So this is the clock for the first flip-flop, that is this one. This is the system clock basically. Let's say call it CLK, and whenever it comes here, this was 1, so whatever the output was here, if it was 0 it would become 1, if it were 1 it will become 0, and so on. So here it will toggle. Let's say it was 0, then again here it will toggle and it will go like this. So this is Q0. Now this Q0 will be the clock for this flip-flop, which is the second flip-flop, and let's call it the third flip-flop. So for the second flip-flop, Q0 is clock. So, and the second flip-flop's T input is 1, so it is also in toggle mode. So what will happen, let's designate the clock edges. So here again, let's say all of them were 1, Q0, Q1, Q2, initially they were all 1, so we are starting from sorry, all of them were 0, so we are starting from 0. So again it toggles here, goes there, again toggles here and here, like that. So this is our Q1, and finally this one is, this is Q1, so the Q1 is clock for the third flip-flop. So the third flip-flop's clock is this, so the third flip-flop will change here and then it will change here. Now what we can see here is, if this, whatever the time division is here, is becoming twice here, and then this is becoming 4 times here, and this is becoming 8 times here. So basically it's increasing by 2. Or if we talk about frequency, the frequency is becoming half with each flip-flop. So if this one's frequency is f, this is becoming f over 2, this is becoming f over 4, and this is becoming f over 8. So this is how we are making the frequency division using flip-flops. And if we want to make f over 16, we need to add another flip-flop, and so on. So yeah, this is how we get frequency division using asynchronous counter.